Good evening. Welcome to the fourth seminar for graduate structural engineers. This is about inspection and appraisal of new and existing structures. So today we'll go through the procedure for how you inspect and how you appraise either new buildings or existing structures to answer the question, how safe is my building? Now, the context for this presentation, this isn't the first time I've done it. I generated this presentation over 10 years ago when I was working in high hazard industry, and it was part of my job to go inspect buildings. And often you've been asked to look at a problem with a building. So you're starting with the premise that there's usually something wrong. The reason you've been called in is because there's something wrong with the building in question. As I say, these seminars titled for graduates, but they're not just for all graduates, they're for all engineers, all structural engineers in particular. I mean, many of whom don't really have that much experience of inspection of buildings and how to assess them, how to appraise their structural integrity. It's got a mainly UK focus because that's based on my most of my experience has been in the UK. It's also pulled from my experience in the high hazard industry. And I must warn you that it obviously contains British humour. So some of the references in it you may not get, and there may be some old cultural references in it. And if you're oversensitive, it's probably time to leave now. So first, a word of warning. If you have been called into a building for inspection and there's a problem with it, you probably won't be popular. They've only asked you because they're desperate. You're not there to tell them what you think it is they want to hear. So don't be misled or misguided into giving a good appraisal for a bad building. And remember that nothing is too big to fail and no building is too important to close. So first of all, some definitions. So inspection, well, that's where we locate defects and non-conformities, usually non-conformities to standards, where the building does not conform to local practices or national standards. And as part of the inspection, you'll be identifying weaknesses in the building, in particular in the building structure. Appraisal, it's quite different from inspection. You are putting a value on it. In this case, you are judging its suitability for that structure for its intended purposes. So part A, we'll go on to talk about structural inspection and answer the question that's often asked, why is my poorly designed, poorly built and poorly maintained building in poor condition after only 50 years? So to start with, you will need some personal protective equipment. And yes, it kind of rains here every now and then, so it's always good to have some waterproof, some wet weather gear and some overalls. You might be going in some dirty places. And if it's for a construction site or it's a damaged building, you'll need fairly standard PPE, including boots, hard hat, high-vis clothing and jackets and so on. Also gloves, masks, glasses, safety glasses. Knee pads are always quite useful. Those are always seen as an optional extra, but a lot of the damage you'll see in buildings is at floor level, and you can only get to it by crawling on your hands and knees. So knee pads are very useful. Tools. Well, let's go the old-fashioned route. Notebook, sketchbook, pens and pencils. Now, these days, you might want the digital equivalent of a touchpad or an iPad to scribble on. Cameras are always useful, and most good smartphones have decent cameras on there nowadays. Torch, because you might be going in the dark. And what I've called a dental style mirror. This is a mirror on the end of a stick. It allows you to see around corners, upon high eaves beams and so forth. And coupled with that, why not get a selfie stick as well to put your camera on? So you can take pictures at an angle you wouldn't normally be able to get to. If you're looking at deformed or damaged buildings, it's always handy to have a plumb bob, a spirit level, and calipers and tape measure and a marble. You can tell if a floor is out of line by putting a marble on it, and it will fall in the direction of the slope of the floor. Similarly, with if walls are out of line, you can put a plumb bob against them and see the angle of the wall. More advanced, you can go on for non-destructive testing. So the things called borescopes or endoscopes. Now, the modern endoscopes have got fiber optic cables and high quality illuminated cameras on the end of them and can penetrate quite far. What you'll need to do is a little bit of opening up, so a small hole, and you can insert your endoscope just like a doctor does. The CCTV, closed circuit television cameras, which can be attached to robots. These are a favourite for drain surveys, but the same robot can be used for going under structures as well. And drones with cameras are quite useful if you want to do an aerial survey, particularly with a roof that you can't get to. A regular one would be a moisture meter, so you can tell the moisture of the particular materials you're using or looking at. So whether you've got dampness in your timbers or in your plasterboard. Ferroscanner to find where the rebar is. Ground penetrating radar for finding underground objects. For testing concrete, now some say that Schmidt hammers are really only good for fairly new concrete and of limited value in very old concrete. But a very useful thing, and it's a cheap and easy thing, a pH indicator to detect carbonation. And typical one will be phenolphthalein. Once you've gone beyond the non-destructive testing, you'll be looking at intrusive work, and simple tools like a hammer, screwdriver, or cold chisel always come in handy. So what training do you need? Well, it's always useful to have a recent eye test. You've got to make sure that you can actually see what you think you can see. Working in confined spaces, that is a special course. The first thing to know is, do you know what a confined space is? And it's not necessarily small, it can be quite large, but it's usually signified by the poor ventilation in there. Now, this is significant in New Zealand because there's a fair amount of underfloor voids that you'll need to get into. And special caution on those, never go into them without an assistant close by in case you get stuck. Working at height, and again, they take special measures for working on roofs, see if there's any protection. If necessary, you might need a lanyard and a harness to go with it, and the training in how to use the harness and lanyard properly. In many cases, for a visual survey or access to a roof, you can use a mobile elevated working platform, and they come in all sorts of sizes these days. If you're in contaminated areas and you're worried about the dust and so on, you may need a respirator. And if you're going to have a respirator, you need training in how to use it, how to keep it sealed, and how to put it on and off. And if you need to be aware of hazards and how to identify them. So what common hazards are you likely to see in your investigations? Well, the first obvious one is going to be building materials like asbestos, lead, solvents, paint, loose cement. Mold is a hot favourite in New Zealand, and in particular black mold, which happily grows on timber and plasterboard here, and even unusual dust and round drugs as well. Bit more serious, ground gases. Again, this is the confined spaces issue. That confined spaces can contain one that could contain methane or potentially carbon monoxide or build up of carbon dioxide as well. So be very careful when working in confined spaces. So the methodology. Part 1, and this is an old saying from surveying, work from the whole to the part. Here's an overall picture, big picture of Whakatane, and just on the hint, it looks like a nice big flat field. But bear in mind, this used to be the seabed. Methodology part 2, work from the outside to the inside. So walk around the building before going on inside. This is particularly important if the building is already damaged or has been subject to an environmental impact such as earthquakes, high wind, or even flooding these days. So check for these signs of distress, in particular ground movement. For example, has there been subsidence or heave? Think about where you are on the land. Are you in the dip? Are you at the bottom of the hill or are you at the top of the hill? In which direction does the water flow? And is there drainage of that water across the site, or are you getting ponding? If so, are there likely to be soft spots around the foundations in particular? Are any of the surfaces leaking? So if you've got drains underground, you can't see them, but you can see their effects by, again, soft spots or puddles in the area where the service should be. Are there water leaks in the building? The water leaks will show up through staining, either on the outside or the inside of the building. Now, often that is a case of the service penetrations not being sealed properly, so water gets in through those pipes and the gap around the pipes between the buildings. There is a potential for trees to influence the ground, in particular where we have expansive clay, as we do have in Auckland. And has it been modified? Has the building been modified or has it been repaired? As well, you should look for. So the methodology part 3, examine your sick patient, as I say. And it's very difficult because you're approaching it new, usually. You've not seen the building before. And really, as I say, the only certain medical investigation is a post-mortem. Now, the only certain structural investigation is to take the building apart, but we can't do that. So we need to diagnose a disease before the patient is dead, to find out what the problem of the building is before the building collapses. Are there symptoms of an underlying disease, i.e. water staining, cracking, and so forth? Is the concrete falling? Can you see rusting? And take nobody's word for it, so take nothing for granted. The thing may not have been built as it's shown on the drawings. And everybody lies, including the owner and the people selling the building and the people operating the building. They may not be consciously lying, but everybody lies. Inspection methodology number 4 is, I say, look for clues at the scene of the crime. So you've come to a building and something has happened to it. What has happened to it? Well, you establish the history of the building. The construction date is very important because that will give you clues as to the type of construction and the materials that were used during that construction. It'll also give you a clue as to the hazards. So as you're probably aware that asbestos was used quite extensively in the building industry in the 20th century. So it didn't really fall out of fashion until 2000, the year 2000. Another thing is to, I say, shut your eyes and see what's not there. So what's missing? So quite often you can go around a building and think, yes, everything's okay, and then walk away thinking there was something odd about it. And then you realize there was no bracing. Sometimes a client will remove the bracing because it's in the way, or they'll remove walls which were providing lateral stability. So assume nothing. It may not have been built in accordance to the plan. The building may not be as robust or as stable as it looks, and sometimes materials are not what you think they are. Sometimes that render could be stone, or maybe the stone is render. And as I say, so you have to use a little grey cells and investigate it as if it was a crime. So bear in mind, of course, that many buildings will be still in service many years after their design life has expired. So when we design buildings, we're looking at a 50 or 60-year design life. And many buildings will be still in use maybe 100 years after they're built. Maintenance is very important for a building, particularly modern buildings, but many buildings don't have sufficient maintenance. They will have suffered a period of either no maintenance or basic minimum maintenance, cosmetic maintenance. Anytime you're short on budget and you want to cut your budget, that's the area of the building maintenance that gets cut. Also, it may be a case that the total cost of refurbishment of that building may exceed the cost of the new building. So the damage to the building, the refurbishment works, the strengthening it to bring it up to standard may be far in excess of what the building is actually worth. Partly because the most valuable part of the building is usually the land it's standing on. Also, if it's a relatively unimportant building, then even the full cost of structural appraisal or the full cost of investigation and intrusive investigation can't be justified. It's just not worth it. And sometimes they'll just take it down on a preliminary investigation. Also, as I say, few buildings exist without some damage. However, how much damage can be tolerated depends on a number of factors. What kind of building it is, what function that building is supposed to perform, where the building is and the nature of that damage. What does the user expect? If the user is used to having a building that's in poor condition and they've been using it quite happily for a number of years, then they may not be up for a total refurbishment. But if there's been some dramatic change, usually following an event like an earthquake or a flood, then their expectations will be different. The repair work needs to be in proportion to the damage, and therefore the cost of the repair work needs to be in proportion to the value of the building as well. Those tips come from the Building Research Establishment in the UK, and their Building Research Digest. So here are a number of degradation mechanisms, and these will influence to a detrimental way the performance of your building. So natural materials like wood will rot and steel will rust, and most metals will corrode in some way. Wood is also subjected to insect attack, so wood-boring beetles, termites, and so on. Not put it on there, but you should be on there. Mold and various fungal attacks are common on wood, and learning how to recognize them is quite important, particularly in New Zealand. As I mentioned, black mold is very sensitive in New Zealand, and the approach is to get rid of it as soon as you can because it presents a health hazard. Animals can be a problem. If you've got earth embankments, they can be undermined by rabbits. Rats, mice, bats and birds like to pick out little bits of your building, particularly wiring. Rats and mice like to munch on wiring. And of course, your building can be subject to vandalism, especially if it's a public building. May not be built particularly well. So your workmanship, when it was first built, can have a significant impact on the durability of the building. May not have been designed properly. So there's already weakness in the structural design, i.e. not enough redundancy. What were they doing at the time? Well, they threw up something quite quickly. So inappropriate building methods. It was supposed to be a temporary building to last, say, 5 years. And here we are 50 years later still using it. Incompatible materials, so mixtures of metals. You've got to be careful how you mix your metals because you'll get bimetallic corrosion, and that'll accelerate the corrosion in the underlying metal, causing structural weakness. And they could have done alterations to the building. The usual trick is to take out bracing because it's in the way of a door they want to put in. And misuse of the building. So if it was originally designed to be a house, and it's eventually ended up being an office or even worse, a gymnasium, then that can have an effect on the building and the building's performance. Drainage around the building can have a big impact on the foundations. So if your drains get blocked, don't overfill or over-soak your area, it can have an influence on your ground and therefore on your foundations. And that will show through in the cracks in the building. So degradation mechanisms common in concrete and common in steel. All of these will lead to your problems in the building as well. These are things to look out for in your investigation as well. Carbonation is a fairly easy one to detect. Simple test from the outside. In case you don't know, it's where carbonic acid, which is a combination of rainwater and carbon dioxide, pours onto your concrete, and it turns it from an alkaline environment, which protects your steel, to an acidic environment, which doesn't protect your steel, and therefore your steel underneath starts to rust. All buildings move, as we mentioned in some of the earlier presentations, and so the changes due to thermal effects, changes due to loading, such as wind, changes due to freezing and thawing of materials can have a big impact on your structure, in particular on concrete, and that can lead to your spalling of your concrete and so on. So you've done your investigation, you need to write a report. So keep your report in a non-technical way. So you write it so a non-technical reviewer can understand the report and make use of it. Avoid vague terms or relative terms. So in fair condition for its age shall be avoided. And that's what they say about me. I'm in fair condition for my age now. That really doesn't say much. Make explicit statements where possible. And if there is corrosion, say how extensive it is, how deep it is, and if possible, measure. So you've got delamination of your steel beam, then measure it and say how much rust you've got on. If the structure is beyond its design life or beyond economic repair, this should be stated. And this will often be the case, that you're looking at buildings which are way beyond their design life as well. Yeah, make lots of photographs, take lots of photographs. There's no excuse now, everybody's got a smartphone with a decent camera on it, and it costs nothing to take photographs. Take as many as you can. You can chuck half of them away if you don't need them. Include the good ones, the relevant ones in your report, and put titles on them, meaningful titles, not just photo 1, photo 2, and so on, but say what it is, where it is, and what defect or strength you are trying to highlight in that photograph. Tell them what the scope of the survey was and any limitations of the survey. So if you were asked to investigate just a crack in the wall, then that's what you say. The scope of the survey was limited to an investigation of a crack in the wall on a particular level, and so on. If you've not looked at the roof, say you haven't looked at the roof. If you haven't looked at the foundations, and probably you're unlikely to get a good look at the foundations, then say that in the survey as well. The report should include a summary of the findings, and hopefully you should be able to comment on the structural adequacy or the integrity or the deterioration of the building, either immediately or for the near future. Now, if you've got an immediate problem, then it's a red sticker job, isn't it? You need to shut this building now. That will normally be quite rare when you're going for your investigations as well. So here's a graded score. So in your report, everything's relative as to some things are better than others, but some things are worse than others. So a brand new building should all be grade A. So no work really needed for the next 8 years. Most buildings will probably fall into the fair category, and that's a B. Minor repairs may be needed. And as it goes on, if it's in poor condition, you will need work within the next 1 to 4 years. And basically, if it's bad, i.e. D, then you'll need to work in about a year or within a year. So it's replacement or significant major rebuild works required. If it's X, it's failed. It's failed and work is required urgently. And it's the kind of work you need to do so you can actually use the building, and you shouldn't be using the building or that part of the building if it needs to be repaired, if it's failed. Part of the report should say what recommendations do you require? So often the process of inspecting a building won't be a one-off. You will have a series of inspections. So you'll start with a plain investigation, a visual survey of the outside and the inside of particular areas. You will also do a desk study as well, if you can. Pick out the drawings either from the client or from the council file. But beyond that, your next topics could be, we recommend that you do further investigation, and these could include CCTV surveys, usually for the underside of a structure, or drains. It's always worth doing drain surveys if there's foundation issues and there's soft ground or puddles or ponding in the area around the building. If you want to get up the roof but don't have time for full accessibility, then a quick view could be done by using a drone survey. And there are a number of specialist companies around New Zealand that will provide that. And it'll do a nice video to show you the roof. Again, it's limited, but it's better than nothing. And particularly very useful for chimneys, because you really don't want that climbing up chimneys. More likely, you'll be going into non-destructive tests. So for steel structures, particularly looking at the welds, if you're worried about the welds, you can go ultrasonic tests, but more likely you're going to be doing magnetic particle imaging or dye penetration imaging as well. For concrete, you'll be doing ferroscanning, so you get a metal detector and find out whether there's any reinforcement in your concrete. Now, they come in a variety of packs, from a very basic beep to a very much more advanced and much more costly full scan, which gives you the depth and size of the reinforcement in your wall or floor. The more advanced ferroscanning is available as a specialist service. Ground penetration goes a step further. You can use GPR actually to go in and find the rebar in thicker slabs. Ferroscanning is quite limited to the depth you can get to, whereas GPR you can go much deeper. But it's also very useful for finding underground objects, such as drainage as well, and services buried underground. Yeah, always make sure you do some pre-survey before you start digging up the ground. You can do some opening up works, so you can recommend you remove parts of some cladding or ceilings. And most modern buildings, most modern office buildings certainly, have these ceilings that just pop out, and you can take off a ceiling tile and have a look into the structure that's hiding behind it. Cladding, well, from the outside, you can cut a section, or preferably take it from the inside, which is removing a little bit of plasterboard and having a look. And this is where you can poke in your endoscope or borescope in there and have a look. But the recommendations that you propose will be based upon the survey you've already done. So combined with the desk study. So these will show the worries, like you are worried about a certain part of the building. I'm worried about the connections, so I need to have a good look at the connections, for example. At the extreme, I suppose, you can test the materials. So you can take a sample of the steel and test it for its grade and strength and density and so on, see what materials actually used. Because historically, a great deal of different grades were used in steel structures. Also, again, as part of your report, you could include recommendations for immediate repairs, preferably using a marked up plan or marked up sketches or marked up photographs. So clear, concise, and make sure you've got a link to it in the executive summary of the report. Make sure you know that you're talking to the client, that they can understand, that you put a big arrow and say, fix this part of the building, for example. Hopefully you won't need to do this, but sometimes you'll have to restrict the use of the building. So does the building have to be closed, or does part of the building have to be closed until it's strengthened or repaired? repaired. Now, a common one would be decks. Elevated decks in New Zealand are often deteriorating and hanging off the building. So what you could do is cordon that off and put that out of use. Staircases, for example, fire escapes are often deteriorated and they can be put out of use. But again, you'd always need alternative fire escape if that staircase is part of a fire escape route. Lots to consider. So some timescales you can suggest for the remediation. So as soon as possible. So if you don't do it, you can't operate the building, basically. That's your as soon as possible urgent work. Please get it done or don't use your building. And then you're into the essential work, which maintains the integrity of your structure. And so on until you get into the more longer term work. So some will be down to general maintenance. Okay, the building's not too bad, but it could do with some maintenance. So you can put certain items on your regular maintenance schedule. And many commercial industrial buildings will have a regular maintenance schedule. It might be on an annual or a 5-yearly basis, but it needs to be done. At the other end, seismic strengthening for buildings. Now in Auckland, we have a very relaxed approach to seismic strengthening. You've got basically up to 30 years to do the seismic strengthening for earthquake-prone buildings, but you might hint to the client that they might want to do it a bit quicker than that. So some further reading. So the Institution of Structural Engineers in the UK produce a number of useful guides and documents. Some are available online, some are no longer available, and some are available sort of via archives. There's a field investigation team called EFIT, and if you're surveying earthquake damaged buildings, they've got a useful guide there as well. The Institution of Civil Engineers produced a report on the inspection, maintenance and management of car park structures, mainly because a lot of car park structures kept having structural faults, structural problems. For low-rise buildings like houses, the Building Research Establishment has a great collection of digests, and it talks all about cracking and settlement and so forth. And for my own collection, these are quite old now. So trees are important in the UK, particularly in the south of England. And so the type of tree you're looking at actually has a big influence on the effect on the ground. So that comes down to its water demand. And so oaks are very demanding of water, and Turkey oaks are very demanding of water as well. And if you just cut the tree down, that can make matters worse than leaving it there. This is a great book, which I don't think is available anymore. Recognizing wood rot and insect damage in building. I got it many, many years ago. And it's a full colour illustration of the kind of rot, certainly in the UK, that you get, and the kind of wood boring insects you get in the UK. I've not seen the equivalent of this in New Zealand, but it would be useful to get. Brands have some guidance, particularly on mould in New Zealand. And there are some tree guides in New Zealand as well. And again, this was a handy pocketbook I bought many years ago for inspecting buildings. The newer version is 10 times the cost and about 10 times as big as well. This is an odd one I've picked up. This is for first responders, basically. It's Urban Search and Rescue, and this is a pocketbook, and it's in waterproof paper, and it's got lots of guides on how to shore up temporary structures if they're leaning over or damaged and so on. So that was structural inspection, and now part B, appraisal. So you've done all that. So what, comes the big reply? Is it safe, says the client? Is it safe to use? And the client will often think that it's a black and white issue, and sadly it's not. So the theory is it's either safe or it's not safe. The truth is it's all a bit grey. There's shades of grey in between. Why do we have this gap? Well, we like to have an adequate margin of safety. So often buildings will not be compliant with modern building regulations or modern codes, but they're not necessarily unsafe. They just have a small or smaller margin of safety than we would like. You then have to justify why that is acceptable or not. So why do we need this adequate margin of safety? Because we're not certain. As we mentioned in previous seminars, we're not always certain of what materials we used. Because we're coming new to an old building, we're not sure what materials were actually used or the standards of workmanship. May not even be sure how the building is actually behaving or the building loading that's on it now. We don't always know how deteriorated or how decayed the building is and whether it's been used in the way it was intended to be used. So I've put together a number of inspection and appraisal flowcharts. Now, each of these are split top and bottom half for this presentation. Now, they have derived, they're my creation, but they're derived from various sourcing, including the iStructE, ICE, BRE, and EFIT as well. So we'll start with the initial assessment. And so before you go out, you want to gather as much information as possible. Now, that may not be possible if you've been called out in an emergency, but if you've been commissioned to carry out a structural investigation, then do a desk study first and grab as much information as you can. Now, the council files available from your local council should contain some useful information among all the dross, but it should, if you're lucky, have the drawings for the building. You also need to know in your industrial environment whether there's any hazardous materials in or near the structure. Is the building being used, for example, as a factory or a chemical processing? So are there any hazardous processes in or near the structure? Those two will conclude, or you should conclude, what risks are you likely to come across during your inspection, and therefore what mitigation you require, what PPE you might require. And don't forget, PPE is the last resort, not the first. If you can mitigate the risk, do so. If you can eliminate risks, even better. So you can then carry out your initial survey on site. And your first question is, does what you see on site actually match what you've got on paper? And if it doesn't, record it. Record the structural condition anyway. Are you seeing anything that's in distress? If necessary, have a quick calculation on any of the parts that you may think are overloaded or in distress. So the bottom half of that flow chart. If those suspect parts are not safe, you might need to take some preventative action before further appraisal, i.e. this is where your temporary propping comes in, ensuring of walls that are out of plumb, extra bracing that you may need. Then you can expose structural elements and take samples and investigate as required. And this is where you come to, is it sound? Is the structural integrity of this building sound? If not, well, can it be repaired? And if so, is it easy? If it is easy, then get straight to it and propose the repairs with the priority, and subject to those repairs, if the building is there for fit for purpose, you can then do your initial survey and survey report. If not, you might have to go on to further investigations. If you're doing a DSA survey, you will probably need to go on to more investigations anyway. But if this is just you've been called in because there's a crack or there's some slight fault with the building, you can therefore, and you don't really see there's any problem with the building, you can complete your report and deem the structure to be adequate for its current use, subject to repairs that you recommend. Okay, so these now link on together from flowchart 1 to flowchart 2. Stage 2 is a structural assessment. So you're not just looking at the building now, you're actually doing some numbers, or will do. So it's a qualitative assessment of the structure. So does the building have any known faults or defects? And that's the first questioning of the building owner or building operator. They may or may not know about the defects, but it's worth questioning the people in the building as to how long these cracks have existed, or how long they've had a leaky roof, for example. So are the defects new or are they time related? So is it time-related deterioration, like rot is a time-related deterioration, corrosion of your steelwork is a time-related deterioration, carbonation, these all occur over a long period of time. So you can then assess the rate of decay, and from that, the expected life of the building, potentially the time to failure. Has the structure been damaged by earthquake, fire, or impact, or even these days, flood, all the things that come with flood? As you saw recently, it's not the water that does the damage, it's what the water brings. Now, I mean, in almost every flood, you'll get a lot of silt coming in, causing a fair amount of damage and debris. And in New Zealand, we've seen what they call slash, which is forestry debris, which is washing down, large lumps of wood washing down and crashing into things, causing quite a bit of damage. So these can impact on your cladding and may even impact on your timber structure, for example. So you need to assess the damage that these events have done to your building, and is there a potential for collapse? And if that, for example, a component of your building is looking like it's failed, can that load be shed elsewhere? So is there redundancy in the building? Can we have alternative load pipes? If not, will the failure of that damaged element cause failure? In other words, so hence you're looking towards progressive collapse. So what are the modes and consequences of structural failure? And that leads on to, is it disproportionate to the cause of failure? So the bottom half of flowchart 2, structural assessment. And we go again, is it robust? Is the robustness adequate? And if we say, if we go down the positive route, yes, 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 then we should be ending up coming back to writing our report. If we go no, can we look at either the loading or the forces being changed? Can we look at changing the factors of safety? Can they be reconsidered? Then you look at, is your analysis model that you've used before, is it too simple? We often use simple beams, simple frames and so on, simple trusses. Is it too simple? Is your model too conservative? Have you undersized components? Have you taken a lower grade when you could have taken a higher grade? So if so, then yes. So yes, you go on to in situ testing and what I call advanced analysis. That will be flowchart 3. Once you've gone through that process of stage 3, you come back to this flowchart and conclude whether it's stable, robust, and fit for purpose. If yes, then you can deem it adequate. If not, do you limit the building use? Do you say it's beyond repair? If yes, then you need to say so. Or are there any temporary repairs required or temporary works required? And then you can write the report. So we'll jump on to flowchart 3, which is about the in situ testing and the advanced analysis. So as we say, we're coming into this not always knowing what the material strengths are. Quite often we don't even know what the materials are. So carry out material test. You can take samples. Steel, you can take a coupon and send it off for testing. Concrete, you can take a cylinder, extract a cylinder and get it crushed, and so on. So that's the material side of it. Then you look at the loads. Have we modeled the loads accurately? Have we overindulged or overloaded it in our analysis model? If we don't know the loads, can you carry out load tests? Now, very simple load tests of buildings usually involve water bags. You get a bag, fill it with water, and see how the building performs, which is usually the deflection of the floor or the deflection of the beams supporting the floor. So it's measured loading using with an in situ test, and that gives you a best estimate of how the floor or the beams perform under their load. If they perform poorly, you may end up putting restrictions on the load. The other aspect of the structure, of course, is how it's supported and how it's restrained. And are those restraints and support conditions known accurately? If they're not, then you need to expose it. Quite often, the weak parts are the connections. And so you may need to take a piece of cladding off or a piece of ceiling plasterboard off and expose those connections, have a good look at them, see whether they're actually doing what they're supposed to be doing. Once you've done that, you can then refine your mathematical model, find alternative load paths if possible, and then give a more accurate, detailed assessment of the building. And that takes you back to flowchart 2. There's 2 more. This is a standalone flowchart, and this is if you're asked to inspect a building following an earthquake. The same procedure could be used for either cyclone damage or even flooding damage. It's the same principle. If your building's been damaged by an environmental effect, then you may be asked to inspect and report on the adequacy of that building and whether they should be occupying the building and using it. So again, you need to consider the risks and don suitable personal protective equipment. See what restrictions are currently in place, because they may just be putting plastic tape around the building to stop people going in as well, which may not be adequate. Collect the drawings and any previous reports. So hopefully you may have had previous experience with this building, as you or your company may have been involved in the inspection on previous occasions. So work from the outside to the in. So you inspect the exterior of the building, and if necessary, look at any temporary propping that's being put in. Once you're content with that, you can inspect the interior of the building once you've deemed it adequately safe to go in. Record the condition of both the inside and the outside, as well as the temporary structures, temporary works, scaffolding, and so on. And then compare those to what was recorded last time, if there has been a previous record. Obvious questions. Is anything more distorted than it was before? i.e., are the walls and columns plumb? Do they line up? Do the columns compare with a 2-meter spirit level? So if you get a long spirit level is usually a very useful tool to have around when measuring the fall of floors and the alignment of the walls and columns and so on. Then you can look at any parts. Have they been damaged? Are there any more cracks than last time? Is there any cracking in concrete encasement to steelwork, for example? Are more parts in visible distress? So are there any cladding bolts missing or loose? Are there gaps in the cladding sheets? So one of the clues will be your building is now leaking where it wasn't before. There's some bolts missing or the bolts are loose, and you can usually rattle them around by hand. And other aspects, for example, ceiling panels. Are they sagging excessively? And one of the causes for excessive sagging is they're soggy, and they're soggy because the roof has leaked on them, and so on. So you compile defect record sheets, preferably with a location of that defect together with a photo. The big question is, are those defects structurally significant? Yes, then you need to notify the client that it's not safe to open. If those defects are not structurally significant, you may want to put small restrictions in local areas, but generally the facility will be in a safe condition to operate. This is something that comes up. This is another one I've invented. I've done a lot of structural assessments for seismic assessments, these ISAs and DSAs. And the question is, once your building is marked as potentially earthquake prone, are we allowed to occupy it? Well, the usual answer is yes, you usually can occupy it because it's in the condition of the event of an earthquake. But you really do need to consider in detail whether the building should be occupied or should be restricted as well. So for example, you've done your detailed seismic assessment, which is down at the top. So if your assessment says it's below 34% new build standard, then you're going down the right-hand side. If it's not, you're going down the left-hand side. Is it less than 67%? So if no, then there's no problem at all. Write your final report with its recommendations and off you go. So as you probably know, if it's between 34 and 67, it's an earthquake risk. And if it's below 34%, it's earthquake prone. And it's usually the earthquake prone buildings that the client gets more upset about because the legal requirement to do something about it. And quite often occupiers or tenants don't want to be in an earthquake prone building. So the first thing you need to do is ask the simple question is, who's it going to kill? Will the failure of any of these elements endanger life? And if the answer to that is no, then you need to ask, will the failure of any of these elements damage adjacent properties? And if the answer to that one is no, then you probably don't have much of a problem and you can carry on occupying your building. So as we see, seismic assessments are primarily about life safety, but they're also about potential damage to adjacent buildings. Not your building, but potential outside buildings. So if either questions to those is yes, you may need to consider whether you've got progressive collapse potential. So if one element collapses, will another element collapse? So can the failed element that you're concerned about, if that fails, can the load be shed to something else? And if it is shed to something else, can that element carry the additional load? And if no, you're looking at progressive collapse. So consider the potential for disproportionate collapse. If yes, that would beg the question, is the structure stable and robust and fit for purpose? Again, this is a question that keeps popping up. And it's a question that should pop up in a structural engineer's mind. Is the structure stable, robust and fit for purpose? If yes, then you can deem that occupancy is acceptable. If no, then you may need to consider limitations on its use. So again, we'll come back to, is it beyond economic repair? And if yes, then it's probably unlikely to be deemed acceptable to be occupied. So consider the options for decommissioning and demolishing it. But quite often you're in the zone in between. So the repairs are not beyond the cost of the building. And so you may deem it acceptable to occupy it even in a limited way. So what temporary works will be required? So quite often a building will be considered earthquake prone if it's got any unreinforced brickwork in it. If you can isolate that area with the brickwork in it, then the rest of the building is good to go in that sense. Okay, that's the end of seminar 4. The next seminar, which will be after Easter, is going into the detail of how you prepare calculations and structural design reports, with a few tips on computer modeling and analysis, and checking calculations and drawings